Please join me in welcoming Dave Stanke to the stage. Dave.
Thank you.
Welcome.
Hi, everyone. Thanks for coming, and thanks so much to CloudBeast for putting on this awesome conference. It's great to be here. Today, we're going to talk about animals. In tech, we have a lot of spirit animals, everything from the Docker whale to the Linux penguin. And today, we're going to talk about sheepdogs. What's a sheepdog? We'll get to that. But first, let's talk about why do we do technology? By now, it's become an axiom, maybe even a cliche, that every business is a technology business. And the kind of technology that drives the most business value these days is software. And kind of everything is software these days, right? We have infrastructure as code and policy as code. All technology is becoming software. And that means that we live in a time when software defines the competitive landscape of business. DevOps is about improving how we make software. What is DevOps? You'll probably hear a lot of different definitions over the course of this conference. I'm going to define it like this. It's an organizational and cultural movement that helps us deliver value to customers in the form of software faster and more reliably. Or to put it another way, DevOps makes your business better. Now, we have evidence to support this. I'm sure people here are familiar with DevOps and Research and Assessment Group, or DORA. And if you're not familiar, you're in for a treat. DORA is a research group led by Dr. Nicole Forsgren that's been iterating for years to understand how DevOps works in the real world. Recently, Dr. Forsgren and the DORA team joined Google Cloud, and it's been really amazing to collaborate with them to really understand what makes teams tick and what makes DevOps groups successful and help their businesses be successful, and to share that knowledge with the community. If you hadn't had a chance to check out this year's report, I recommend it. You can find it at cloud.google.com/DevOps. If you've read last year's report, read this one. It's got a bunch of interesting new stuff, including really practical advice on how to make a DevOps transformation in your organization. So the research shows us that team performance is predicted by 4 key metrics. First, cycle times. How long does it take for a code change to get delivered to users? Second, what's the interval between releases? Are we measuring this in terms of releases per year or releases per day? Third, how often do deployments fail and require remediation? And fourth, when that does happen, how long does it take, on average, to make those fixes? What is the mean time to repair, or MTTR? What we found is there was a huge spread between levels of performance on these metrics, from low performers up to elite performers. The really high performers, these elites, are way ahead of the pack. You may have seen these numbers before. I've seen them many times, and every time I'm just blown away by them. These are really big numbers. But there's a lot of numbers in the world. What makes these numbers so interesting and important? Well, DORA has shown that teams who score well on these measures are driving better business outcomes through technology. It goes as far as this. Companies with teams that succeed at DevOps have stock values that outperform their competitors. This stuff works. DORA has also shown that adopting modern infrastructure, especially cloud computing, is an influential factor in driving excellence. It helps organizations achieve speed, stability, and availability. Let's talk about cloud. Cloud computing is really revolutionary. It really fundamentally changes our profession. Instead of dealing with machines and boxes, we're now dealing with virtual infrastructure. And so the way that we provision and modify and retire our software is now really fast and really fluid. And that flexibility supports a new kind of creativity. It also requires new ways of thinking. There's a well-established metaphor about this. Before the cloud, servers were pets. They had names. We knew them well. We knew their abilities and we knew their quirks. We cared for them as individuals, and our relationships with them may have spanned years. In the cloud, servers are livestock. We move them around in herds. Think about like a flock of sheep going out to the meadow. It's just this mass of fluffy wool. We don't know them as individuals. We only know them in bulk. And we improve our systems not by operating on them individually, but by improving the ways that we operate them on them in bulk. I think there are actually more than two animals in this zoo. We can look at infrastructure on a spectrum. So at the far end is bare metal. These aren't even quite animals. They're more like houseplants, and that's great, but they're not exactly dynamic companions. Then we have VMs. Those are our pets. And we move into cloud instances where we have the livestock. We don't treat them as individuals, but we can still identify them. When there's a new sheep born in your flock, you're like, oh, look at that sheep. I see that. But with something like Kubernetes, it's hard to even really pinpoint one of the individuals. They're always blinking in and out of existence. They're more like a swarm of butterflies. Fun fact, the technical term for a group of butterflies is a kaleidoscope. And that's with a K, of course. At the far end are the emerging serverless platforms. And these are kind of like everything and nothing all at once. They're like one of those beings of pure energy from Star Trek. So this is evolution. And as technology evolves, best practices evolve. And that's why Cloud Bees and Google collaborate on so many levels, all along the spectrum, to help you succeed at whatever point fits your needs. But I'm troubled by something. When I talk to people about their CI/CD, what I often find is that the CI/CD systems lag behind the production systems that they're operating on. The CI/CD is not as highly evolved. I think you know what I'm talking about. I often hear something like this. We moved to the cloud, and so I had some production boxes sitting around. So I took Jenkins and installed it on one of them, and now that runs our deployment pipelines. It's under my desk. Well, it was under my old desk because I moved a few years ago, and I didn't know the root password, so I didn't want to power it down. So it's under Floyd's desk on the second floor. Or was that the 8th floor? It's around here somewhere. So we're using legacy DevOps systems to operate on rapidly modernizing production systems. These are sheepdogs, pets that manage livestock. And we love our sheepdogs dearly, but they're holding us back. They're fragile, they're slow, they're overburdened. Tell me if this sounds familiar. The build is broken, and you're not sure whether it's a bad commit or if the CI system is wedged. Or what about long build queues or overflowing hard drives? Or about that thing you have to do to CI once in a while, but only one person knows how to do it, and she's on vacation, and everyone's just like, oh, no builds today. Okay, but why does it matter? Well, why does CI/CD matter? Let's go back to those key DORA metrics. Optimizing these metrics is good for business, and CI/CD plays a big part. Commit to prod time. Some of this time, maybe a lot of this time, we're waiting for our CI jobs to complete. They're slow, they're flaky, they're piling up in a queue. So we need CI/CD that is fast and scales. Deploy frequency. Again, we need speed and scale. We also need adaptability, because changes to code often require changes to the build process. So we need CI/CD that can evolve along with the code that it builds. Change failure rate. How do we reduce that? Well, we reduce that by helping devs write better code. And that means fast, insightful feedback loops need fast, insightful, reliable CI/CD. And mean time to repair. Well, fast fixes need fast tests and dependable deployments. We're going to need to up our game on CI/CD for that too. So, fast, scalable, adaptable, secure. These are the things we want in our production systems, and to get there, we need these in CI/CD as well. We can get there. We can modernize CI/CD. That means we need to retire the sheepdog. We should adopt something more like like a robot cat. So let's look at how we can evolve our CI/CD and modernize it using cloud-native technologies. Now, I've just finished talking about how essential our CI/CD systems are and how it's a big problem when they're not reliable. So now I'm going to tell you to rip everything out and replace it with something new, right? No. I want to talk about incremental steps. I'm really excited about where we're headed. But I'm also glad that no matter where we are along this spectrum, there are concrete, small things we can do today. Let's continuously improve our CI/CD. Every step moves us forward and helps us perform better. So first, let's look at how we can augment an existing system, upgrade in place. I want to show you some techniques that use the cloud to enhance our traditional Jenkins pet. At Google Cloud, we have a dedicated group of software engineers called the Cloud Graphite team. Many of them are here with us today. They provide integrations to popular open source tools that make it super simple to use these tools with GCP. For example, they work on the Terraform GCP provider, Ansible modules on GCP, Logstash plugins, and Cloud Foundry on GCP. One of Graphite's priorities is making really first-rate Jenkins plugins for connecting from Jenkins to Google Cloud. That includes the OAuth plugin for authentication, Google Cloud Storage for build artifacts, Compute Engine plugin to provision worker nodes, and the Kubernetes Engine plugin for deploying to GKE. A lot of what I'm going to show you makes use of these plugins. So, scalability. A big challenge for CI/CD is scalability, because test and deploy is a really seriously spiky workload, right? First thing in the morning, the CI/CD system is sitting idle. Then everyone starts doing builds, and it backs up, and everyone's getting mad. And then eventually all their builds clear out, they go home, and it clears up again. So now you got plenty of build capacity just when nobody needs it. So most of the time, the CI system is either under-provisioned or over-provisioned. At least that's what happens when we have a fixed pool of worker nodes. This is a pet with pets. A Jenkins master that operates a fleet of persistent workers. The hard part is that it's impossible to get the exact right number of workers. If you have enough to avoid queuing at peak times, then you have a lot of unused capacity at idle times. It can be hard to justify that bill to management. But the cloud is fundamentally built for elastic scaling. With the cloud, instead of a pool of always-on workers, we can provision workers on demand. We create a template, and then whenever we need a build, Jenkins spins up a worker just in time. So we can scale up to build as many jobs in parallel as we like, and we pay only for instances when they're in use. Each build gets a unique clean VM, which is recycled at the end of the build. This is also a great use case for Google Compute preemptible instances, which are much cheaper than regular instances. To make it really easy to run these on-demand workers, the Google Graphite team makes a GCE Jenkins plugin. It automatically provisions and terminates compute instances for workers. You can find that in the Jenkins plugin manager by looking for Google Compute Engine. Another benefit of on-demand agents is that they're easy to keep up to date. If there's a security vulnerability discovered on the worker nodes, you don't need to go around and patch each one individually. You update the template, and then from then on, every new job gets that new, secure machine. So far, I've been talking about things where the Jenkins master doesn't even need to be on modern infrastructure. It can still live under your desk or Floyd's desk, and your workloads get more scalable and more secure. Now let's shift another notch on that spectrum and see what we can get. What if we run Jenkins on cloud-native infrastructure? And in particular, I'm talking about Kubernetes. It's surprisingly easy to get started. In Google Cloud's Kubernetes marketplace, you'll find wizards that will install Cloud-Beast Core or Jenkins on your GKE instance. You'll see familiar Jenkins UI, and you can bring over all of your plugins and job configurations. Right away, you'll get lots of Kubernetes goodies like self-healing. With GKE, you get managed clusters and features like automatic patching and auto-scaling. Here's one of my favorite things about running Jenkins on Kubernetes. If there's one thing that's consistent across the organizations that I talk to, it's a lack of consistency. Every successful business has lots of applications, built at lots of different times, using lots of different languages and frameworks and dependencies. This is a beautiful mosaic. But it's hard on CI, because every application has a different tool chain. We usually solve this by loading up our build workers with all sorts of tools, Java and Python and .NET, and multiple versions of each. They're all fighting with each other and causing conflicts. We are overfeeding these pets, and they're not healthy. With Jenkins on Kubernetes, we get the advantage of containerized workers as code. This goes a step further than the on-demand compute instances we talked about earlier. Now, instead of having a pre-baked template stored somewhere on your cloud config, the worker definitions are saved and versioned right along with the code that they build. For each build stage, Jenkins will conjure up a Kubernetes pod with just the right tools for that job. And that means no more fat pets. If a developer comes to you and says, "We're excited to use this cool new language. It uses a special build tool," you don't need to cringe and worry about whether it's going to play nice with all the other tools. They can just add a line to their Docker file, and that special tool will appear right when they need it, and then poof, when they're done, that tool is gone, not messing with anything else in your infrastructure. Let's talk about portability. By nature, software is weightless. It's easy to move it around and connect all the systems together. But in real life, things aren't always so smooth, right? In so many subtle ways, cloud native is different from cloud, is different from on-prem, and that causes duplicated efforts and dead ends and headaches. This is why hybrid is such an important topic right now. How do we minimize friction when our workloads span across multiple public clouds, private clouds, and on-prem? Google's answer is Anthos. Anthos is a managed infrastructure stack that builds on open source platforms like Kubernetes and Istio. Anthos provides a consistent substrate across heterogeneous environments. So the same software runs on GCP, in your data center, even on AWS, all with a unified control plane. And one of the things I love about a hybrid setup is that it enables burstable workloads. So your production load might look something like this. Over the course of the week, it gets heavier and heavier, and then on the weekend, people go home, and there's less of a load. So what do? You try to even it out, and you go and buy some hardware. All right, that looks good. It's about average of handling the load. You can probably see the problem here. Those users are not happy. So what do? You go and buy all the hardware. Now we can handle all the spikes, at least unless we get any more successful. Don't let that happen. So we went and bought all this hardware, but then a bunch of it is sitting idle all the time. Still has to be managed and costs us money and makes us sad. So hybrid lets us do something where we can have a consistent set of hardware that handles most of our load and spike into the cloud on demand as needed. In order to manage across all of these servers in various different places, we can use Anthos to have a consistent experience no matter where the workloads are running. As I mentioned, CI/CD is the burstiest of workloads. We start on Monday, the engineers roll in, they're a little hungover, they haven't really gotten up to speed yet. Tuesday and Wednesday, people are starting to get going. Thursday, everyone's rushing to get their builds done before the Friday freeze. On Friday, there's still a couple, last-minute fixes. And then Saturday, Sunday, everyone goes home. So why not use all of our capacity as elastic cloud compute? Which brings us to cloud-native CI/CD. Let's think about a truly modern CI/CD, something that harnesses all the power of the cloud and bakes in everything we've learned about DevOps. What would that look like? According to the Cloud Native Computing Foundation, or CNCF, cloud-native computing is defined by a focus on things like containerization, immutable infrastructure, declarative APIs, and loose coupling. The cloud facilitates these practices, and we can build on them to make a CI/CD that will grow into the future. I think there's another key aspect here as well. It's not necessarily part of the cloud-native definition, but it's important, and it's openness. Over the past 10 to 20 years, organizations of all kinds, from startups to huge enterprise, have embraced the open source exchange of ideas. I strongly suspect that it's no coincidence that this is roughly the same time frame in which we've seen the rise of cloud computing and DevOps. We've learned from experience that when we solve common problems together, we all benefit. We all get stronger common foundations, which gives us more time to focus on building our differentiators. Right now, these threads are coming together into a shared effort to define CI/CD for the next generation. Earlier this year, the Continuous Development Foundation, or CDF, was launched. The CDF is a sister organization to the CNCF, and its mission is to establish common best practices and encode them into open source software. The founding members of the CDF include organizations like CloudBees, Google, CircleCI, JFrog, and Capital One. We're working to reduce fragmentation and establish durable standards that let us innovate at a higher level. The first 4 open source projects in the CDF are Jenkins, Jenkins X, Spinnaker, and what's that? That's that robot cat we were looking for. Meet Tekton. Tekton is an open source framework for CI/CD. It originated at Google, and now it's part of the CDF. It runs on Kubernetes, so it inherits cloud-native benefits like scalability, encapsulation, and declarative configuration as code. Tekton distills best practices for modern CI/CD into a set of universal primitives. Just like how Kubernetes is a universal runtime that make applications portable between different infrastructure, Tekton makes CI/CD workloads portable. We're building common CI/CD functionality into a shared platform. This lets us focus on building opinionated solutions on top. Jenkins X is CloudBees' implementation of a Tekton executor. It natively runs Tekton pipelines, so workloads are portable to any system that can run Tekton, which is any Kubernetes cluster. Because it's from CloudBees, it has a familiar developer experience and supports existing Jenkins projects. I mentioned earlier that Google Cloud and CloudBees are working together in a lot of ways. You've heard about some of them at this conference, and Jenkins X is a prime example. CloudBees Jenkins X is a stable release channel supported by CloudBees, and Google Kubernetes engine is the first platform supported by CloudBees. In fact, the engineers who developed CloudBees Jenkins X use Jenkins Cloud as their development platform. Wherever you are in the cloud spectrum, and wherever you're headed, I hope this talk has helped you think of ways that you can benefit from more modern CI/CD. So let's circle back to why it matters. Let's ask ourselves, what's the business of our business? What product or service does it provide? I'm willing to bet that your mission is not to provide a CI/CD platform to your end users. Vendors, don't answer that question. But for everyone else, is that what your company does for a living? No. Whatever your mission is, you want to spend as much time as you can achieving that mission. And when we have CI/CD that simply works, that simply scales, that's secure out of the box, that's when we can really focus on delivering software. We can use our tools to bring unique value to our users. I want to close with this thought. We've seen the value of moving forward into modern practices like DevOps. We know that whatever our business is, software development is an essential capacity. And to succeed in software, our production systems need fast, frequent, reliable deployments. They need to support experimentation and quick recovery. Rapid adaptability at scale is essential to our business success. It's an essential feature of our business. What is the engine of that adaptability? CI/CD. So practically speaking, your CI/CD system is a production system. And it needs to be just as performant, just as scalable, just as reliable, and just as secure as the rest of your production infrastructure. So it's time to say, Sheepdog, thank you for your work. You've been a faithful companion. Now come curl up by the fire and rest. It's time for modern software automation that can deliver us into an exciting new cloud-native world. Now we want to hear from you. So please come find my colleagues and me at the Google sponsor booth, or tweet at me and tell us what you've learned. On behalf of Google Cloud, thank you.
Thanks. Thank you, David.